All right, so today we're going to spend another day on 2-3, and we're going to look at something a little different today. So this first example, they want us to determine when are the intervals of the graph positive and negative. So they give us this function right here, y equals x squared minus 2x minus 3. And we're going to do the same thing we were doing on day 1. Okay, I want to go ahead and set that function equal to 0. And then factor it. So 0 equals x squared minus 2x minus 3. Okay, we have that set up right there. We go ahead and factor that down. There's 3 terms. We're going to reverse FOIL. Okay, so what multiplies to give me negative 3 but adds to give me a negative 2? It's going to be x minus 3, x plus 1. Okay, so we go ahead, we have that factor. All right, now I have to solve that. So that's where last time we met, we said we're going to break it, set each equal to 0, and solve. When we do that, we're going to get solutions of x equals 3 and x equals negative 1. Okay, so I have my 2 zeros. We need to go ahead now and list them from least to greatest. So I have x at negative 1, and I have an x-intercept at 3. Okay, so what I'm going to do is I'm going to go ahead and plot those points on the graph. Okay, so we have a dot at negative 1. We have a dot at positive 3. Okay, I'm going to go ahead and sketch this graph. Okay, when we sketch this, I look out front and I see that my x squared, my a term out front, is positive. So that tells me that my graph is going to open up. Okay, so just a totally rough sketch. Looking something like this, go down, back up. Okay, it's not the best graph, but it'll get the job done. So our question now is, when is this graph positive? So when they ask you when is it positive, we want to know when are we above the x-axis. So looking at this graph, I am above the x-axis for this section over here and this section over here. Okay, so we need to list out the intervals. Okay, what is that? So for this first one right here, that keeps going up and to the left for forever. So I want to know, what is the smallest x value we have where we are still above the x-axis? That's going to be from negative infinity, and we are positive all the way until we get to the 0 right here, which is negative 1. When we get to negative 1, our x value actually is 0. So I'm going to go ahead and throw a parenthesis around that as well. We are also positive over here to the right. So I'm going to put and. We are going from 3 to positive infinity. So 3, comma, infinity. Okay, so that would be, or those two are the intervals where our graph is positive. Now for the other one, we want the negative. We are negative or below the x-axis in this region right here. Okay, so for this section right here, we are below the x-axis. We are negative. So I need to see, okay, what x values does that happen for? We're going from negative 1 to positive 3. And once again, we have parentheses going on because at those points, at negative 1 and at 3, our y value is actually 0. Okay? So whenever you do the positive negative, you're always going to have parentheses going on. Okay? So that's determining when we have positive negative intervals. I need you to go ahead and do the try it on your own. So same deal. You're going to factor, set equal to 0, and go from there. The second type of problem, and the last type of problem we're going to look at today in section 2-3, is factored form of quadratic. So we've talked about vertex, we've talked about standard. Today we're going to do factored form. And you're going to be asked to write an equation. Okay, we're going to try to keep it pretty simple. So with this, I want us to write an equation of a parabola with x-intercepts at negative 2, negative 1, and it passes through the point negative 3, 20. Okay, so if I look at my original, okay, my y equals a, x minus p, x minus q. We need to plug in everything that we know. So we know right away that we have an xy point. Okay, x is negative 3, y is 20. So I'm going to go ahead and substitute that in. Wherever I see y, we're going to throw 20 equals, I don't know a, it's the same goal. Okay, so when we had vertex form, our goal was to solve for a. It's the same deal today. Okay, so we got to solve for a. Our x value is negative 3. So wherever I see an x, I'm going to throw in a negative 3. Lastly, we need p's and q's. Okay, so I have zeros at negative 2 and negative 1. Okay, the only thing we need to watch out for here is that when we plug it into the parenthesis, it needs to be the opposite. Okay, so whenever we're inside a parentheses, it's opposite what we think. So instead of negative 2, I'm going to plug in positive 2. Instead of negative 1, I'm going to plug in positive 1. Now that I have everything plugged in, we go ahead and work it out. Okay, so I'm going to have 20 equals a. Negative 3 plus 2 is a negative 1. Negative 3 plus 1 is negative 2. So 20 equals 2a. Go ahead and divide by 2. A is going to equal 10. Okay? So now that I found a, we can write our equation. Whenever we write our final function or final equation, we're going to plug everything in except x's and y's. So it's going to be y equals 10, x plus 2, x plus 1. Done. That is the factored form right there. Okay, so factored form. I know it is factored form because I have two parentheses and they both have x's in them. We can easily find our zeros or x-intercepts from there. Now, sometimes, and on this problem they didn't ask you, but sometimes they may ask you to go to standard form. So the way we're going to get to standard form is to multiply it out. Okay, so below this line right here, I'm going to do the standard form. To get to standard, you go ahead and FOIL first. So when we FOIL this out, we're going to have x squared plus 3x plus 2. Okay, I did that all in one step, but it's first out in last. And then the last thing you would need to do is distribute the 10 in. So you end up with y equals 10x squared plus 30x plus 20. And that would be my standard form. So from there, we could find A, B, and C if we so choose. Okay? So I need you to go ahead and do the try it at the bottom of this page, and then if we go to page 36, you have another try it as well. So make sure those are done before you come to class, and then if you have any questions at all, send me an email, and I'll be willing to help you out.